Graph of function. Previous lecture, we have studied about y is equals to mod x. Now, in this lecture, we are generalizing as y is equals to fx is in the mod, or if it is given y is equals to f of x is in the mod, or maybe the function is given mod of y is equal to fx. Then how to draw the graph in these cases, right? So first we are starting with y is equal to fx is in the mod. Y is equals to fx is in the mod. So assume a function is given y is equals to x minus 1 into x minus 2 and whole this thing is in the mod, right? The complete function is in the mod. So first is the axis, y-axis, x-axis. At 1 and 2, this will be 0, right? We know that this is the graph of parabola or the polynomial, positive, negative, positive. So graph is going something like this, right? This is the nature of the graph, right? When we are trying for y is equals to, this is the graph for y is equals to x minus 1 into x minus 2. But we have to use mod in this. If we are using mod make this quantity as complete positive. When this quantity is positive overall, the graph will be same. When x minus 1, x minus 2 is positive, graph will be same, right? When this quantity x minus 1 and x minus 2 is negative, so we have to convert this to positive. How to convert this to positive, right? This will go something like this. So we have to remove the graph of the graph between 1 to 2, right? This one that is given as the negative one. So just we are removing this graph between 1 to 2 if this is negative, right? And then this complete graph is called the graph of y is equals to x minus 1, x minus 2 whole is in the mod. So when we remove between 1 to 2 the part, so we are getting this graph, right? This is the graph of modulus of x minus 1, x minus 2, right? Let's try one more graph for y is equals to x minus 1, x minus 2, x minus 3 whole is in the mod. First, what you have to do, draw the graph of y is equals to x minus 1, x minus 2, x minus 3. This is the y-axis, right? X-axis, all the 3 points, 1, 2, and 3. Greater than 3, positive, negative, positive, and negative going to minus infinity. Now we have to draw the graph for mod of this. So what we have to do, first we have to see the negative portion. So this is the negative portion and this is the negative portion of y. Now we have to convert these negative portion into the positive one. So this is the positive portion of this, and this one is the positive portion. The same graph we have to repeat above this, and then remove the graph of the negative portion, right? So we have to remove this graph, the negative portion graph below 1, and similarly between 2 to 3. So all the function is going up. This is known as graph of modulus of this function, right? So this is the function when fx is in the mod. Now, the second is of this when we have to draw the graph of y is equals to f of x is in the mod, right? So first we have to draw the graph of y is equal to fx, and in place of x there is given mod x. So we have to just see the symmetricity about y is equal to this function is given y-axis, right? So symmetricity about the y-axis means, like, again, start with the simple one, mod x minus 1. So first we'll draw the graph of y is equal to x minus 1 in the positive direction only, right? In the positive direction, y is equal to x minus 1. At x is equal to 1, y will be 0, and x is equal to 0, right? You can see y is equal to 1, and x is equal to 0, y is equal to minus 1. There is a point. For x greater than equal to 0, this is the graph, right? Now, this is the graph of y is equal to x minus 1. Now we have to draw the graph for mod x minus 1. So what you have to do, this graph will be same, right? And going like this, right? This is for x minus 1, and this is for again x minus 1, but one minus sign we have to give to this. So minus x minus 1, this is the graph of y is equal to, we can say the complete graph in the sense is mod x minus 1. So only you have to do just remove the graph for x less than 0, then copy paste this graph when this is greater than 0. We'll get the graph of y is equals to x is in the mod. So going for one more example for this, mod x minus 1, mod x minus 2. Now, mod x minus 1, mod x minus 2. So let's draw the graph of x minus 1, x minus 2. We know that x minus 1, x minus 2 is something like this. This is the graph of y is equal to x minus 1, x minus 2. Now, we have to draw the graph of, in place of x, there is mod x, right? So this graph of this, right? So first you have to draw the graph up to x greater than equal to 0, right? This point. You can put x is equal to 0, you are getting y is equal to 2. This point is 1, 0. This point is 2, 0. Now, x less than 0, this will be something like this, right? The same symmetricity about y-axis, right? This is the complete graph of mod x minus 1, mod x minus 2. Okay, and the last portion of this mod graph, mod y is equal to fx. Let's start with simple y is equals to x minus 1, x minus 3, and we have to draw the graph of mod y is equal to x minus 1, x minus 3. First, start with the basic, draw the graph of x minus 1, x minus 3. This is the graph of x minus 1, x minus 3. This is the point 1, comma 0. And this is the point 3, comma 0. We have to draw the graph of mod y, right? In this case, what you have to do, just see, this is for y greater than 0, right? When y greater than 0 is given, so you have to draw the graph in positive and negative both. If y is less than 0, this portion, when this is y is negative, just remove the graph. And again, for greater than 0, for greater than 0 and less than 0, you have to draw the graph. So this is the graph for mod y is equal to x minus 1, x minus 2. When graph is positive, you have to draw this in negative also. When graph is negative, you have to cross this graph. When graph is negative, again, you have to cross this. And for positive, you have to draw in the positive as well as in the negative part. So in this case, why we are doing this, right? We know that if mod y is equal to 2, then value of y is plus or minus 2. And if mod y is equal to minus 2, right, no values of y is possible, right? No values of y is possible. Now, application of this mod function is in Signum X. Signum function, right? Signum function is defined as fx greater than 0, function will be 1. If fx equal to 0, function will be 0. And if fx less than 0, function will be minus 1. Right? Or with the help of mod, this is fx is in the mod upon fx, right? When fx greater than 0, right? So we can say fx is in the mod with fx will be 1 only. At 0, this will be defined as 0 only. At minus, when fx is negative, this is coming as minus 1. So Signum function we can define as mod fx upon fx when fx is not equal to 0 and fx is equal to 0 when this function is given as 0, then SGN fx will be 0 only, right? So we are dividing this into two parts. One part, when fx is 0, the function will be 0. If fx is non-zero, then it will be mod fx by fx. So for fx greater than 0, you are getting 1. For less than 0, you are getting minus 1. At 0, this is given, this will be 0. So if I'm drawing the graph of y is equal to SGN x, so for x greater than 0, graph will be 1. For x equal to 0, this will be 0. For x less than 0, it will be minus 1. So the simple graph will go there, right? This is the axis. For x greater than 0, this is the graph of y is equal to 1. At 0, we are getting 0 is 0. X less than 0, this is the graph. Y is equals to minus 1. So this is the graph of Signum function. Domain in this case, we can see domain is R and range in this case is the values minus 1, 0, and 1. 3 values you are getting, discrete values we are getting as these 3, right? No. So one of the best example for the graph is fx is in the integral part. So first you have to understand what is the meaning of this integral part. The integral part, like if I'm saying the number is 5.23, integral part of this is this number 5.23 is lying between 5 to 6. So this will reach to the left of this integer. So answer will be 5. Can we think for minus 5.14? Is it? So see this carefully. This number minus 5.14 is lying between minus 6 to minus 5, and left integer for this case will be minus 6, not minus 5, right? For negative, this is going for the left integer, that is minus 6 only. If only fraction is given, 3 to 0.32 is in the greatest integer. So this 0.32 lying between 0 to 1, so integral part will be 0 only, right? Now, how to draw the graph for y is equals to greatest integer of x. This is also known as a step function or box function, right? The reason is to say this, the step function or the box function is, if we'll draw the graph, we'll get a step or a box would be there, right? So let's start for y is equals to greatest integer of x only. This is the step function. So one by one, stepwise, we have to go for this, right? Case first, when x is lying between 0 to 1. So the value of y will be 0 only. So in between, x lying between 0 to 1, then we have to draw the graph of y is equal to 0, right? When x is lying between 1 to 2, the value of y is equal to 1. X is lying between 2 to 3, value of y is equal to 2. X is lying between 3 to 4, the value of y is equal to 3, and so on. So if we have to draw the graph, right, in this 0, 1, 2, 3, 4, and so on, right? Minus 1, minus 2, right? When x is lying between 0 to 1, y will be 0. So this is the graph, right? At 1, this will be 1 only, and 1 to 2, y is equal to 1 is the graph. At 2 to 3, y is equal to 2 is the graph. At 3 to 4, y is equal to 3 is the graph. At minus 1 to 0, y is equal to minus 1 and minus 2 and so on. So you can see if someone is standing there, right? You can see this is the step. He can jump to this point or going anywhere. That's the reason this is known as a step function, right? The function is in the form of, like, we can draw this. So these are the function, which functions हम लोगों ने देखे, right? Now, how to use these functions in different form. So one more thing, you must understand this, very important for solving the question, that's known as sifting of graph. Sifting of graph, right? If the function y is equal to fx is given, and you have to draw the graph of y is equal to x plus or minus a. So what you have to do, right? Like if I'm saying the graph of y is equal to mod x is given, now you have to draw the graph of y is equal to x minus 1 is in the mod. So what you have to do, right? See, y is equal to mod x is a graph, something like this, right? We have already seen this, right? X minus 1 is in the mod, so we have to move this graph. If there is a minus sign, minus 1 is there, so you have to move this graph to the right of 1. So the graph in that case will be this complete, this thing shifting to 0 to 1, it was 0, 0. What if I'm saying you have to draw the graph for y is equals to x plus 1 is in the mod? So you have to draw the graph, this graph, right, mod x graph to the left. right? This is -1, 0. This is called sifting of graph, right? The sifting to the left or right depends on x -1 is there, so going to right. X +1 is there, then you have to go left, right? Now, what if the graph of y is equal to fx is given, and we have to draw the graph of y is equal to fx plus or minus a? So you have to add or subtract one with y or the complete fx. Like the same example I'm taking, y is equal to mod x. We have to draw the graph of y is equal to mod x plus 1. See, y is equal to mod x, this graph. Now you have to draw the graph of mod x plus 1. So complete graph will shift to 1 unit, right? This is the graph of y is equal to mod x plus 1. Now think, what would be the graph of mod x minus 1, right? So the complete graph will start or go down by 1 unit. So this is the graph, right? Y is equal to mod x minus 1. Now applying this graph, we have to understand algebra of function, right? The function or operation on algebra, right? F and G are two function, and we have to apply the concept for F and G. And if we have to add two function fx plus gx, then the important part is the domain of both the function will satisfy. Means we have to take intersection of both the function, right? That's written x1 intersection x2. If we are going for, right, we have to add this, subtract this, multiply this, or we have to divide this. But in the division, you know that anything 0 in the division will not define, so gx must not be equal to 0, right? Or we have to, cx is any function given, so c fx, right? C is constant, so we can go for this number and apply this theory, right? Now, how to apply this concept into the question? Like, if I'm giving you y is equal to under root of x minus 1 plus under root of 6 minus x, you have to find domain of this function, right? Let this is fx and this is gx. So we know that with under root, x minus 1 must be greater than equal to 0. Similarly, 6 minus x must be greater than equal to 0, right? Make a line, right? 1, x greater than equal to 0, mark this for greater than equal to 0. Secondly, x less than equal to 6, so mark this x less than 6. Now combine this. Combine this means the common portion, intersection of both this, right? So intersection is the common portion, that we can see 1 to 6. This is the common domain of the function, right? Second case, like y is equals to x minus 4, 3 minus x is in the under root plus under root of x, right? So we know that from first, again, x minus 4, 3 minus x must be greater than equal to 0. Right? So first case is there when both are greater than equal to 0. And case 2, x greater than equal to 0. Let this is fx, this is gx. Draw the number line. This is the number 3 and 4. Right? Put any value, so this is coming as negative, positive, negative. The sign is changed there, right? So 3, 2, 4. And second, x greater than equal to 0. So let 0 is there. So x greater than equal to 0, we are marking there only, right? What is the common portion? So 3 to 4 is in the closed interval. So two functions are given. We have to carefully see the function and we have to apply the concept, right? And as I said, in the when we have to find like more than two functions are given, x minus 1, x minus 4 plus 1 upon x minus 10 plus under root of x minus 3. Now, it's a complicated question. We can say like we have to apply all the concept at once, right? For log, we know that x minus 1 greater than 0, x minus 4 greater than 0, x minus 4 not equal to 1. For second function, x minus 10 not equal to 0. For third function, x minus 3 greater than equal to 0. Apply all the three in one, right? X greater than 1. That's a good point. X greater than 1. Second, x greater than 4. Okay. X greater than 4, right? X not equal to 5, right? Except 5, all the values. Till this, we are getting 4 to 5, 5 to infinity. Now again, x not equal to 10, except 10, all the values, right? And now x greater than equal to 3. If this is 3, so now we have to see what are the common portion in this. So we can see between 4 to 5, 5 to 10, and 10 to infinity. So we can write 4 to 5 union 5 to 10 union 10 to infinity, right? X belongs to a domain of this function is, right? Or we can write this answer as 4 to infinity negation the value 5 and 10, right? X belongs to this, okay? So now we have to start the few questions that was asked in previously in JEE mains. So let's apply the concept on the question.